It was interesting looking at that data. I think the number 2 was about safe and secure. Obviously, in crypto and in blockchain writ large, one of the big challenges is, there's some shady activity sometimes. People unknowingly are making mistakes and losing what they have. So security and being comfortable that the dApp you're working with is one you can trust is important in our space. And so I'm very happy to welcome our next speaker up to talk specifically about that. How do we make sure that projects are safe? So please join me in extending a warm Avalanche welcome to Connie from CertiK.
So, hi everyone. Thank you so much for having me here. And today we're going to share some of the learning and experience that in the terms of security. So the topic that we're going to talk for today is how to secure the Web 3.0 Web3 war. So we're going to share some of the insight, hacks, CrossStream exploit, and some of the security best practices that able to helping the developer to building a more safety applications. Yeah, so CertiK, we are a blockchain security company. So we have a mission critical in making a Web 3.0 even more secure than Web 2.0. And formal verification is our DNA, meaning that we are founded by two of the experts in the field. They are both professors from Columbia University and Yale University. And so far, we have been secure more than 3,000 projects and giving more than $360 billion in assets. And we are also, we're backed up by investors from the top tier line, for instance, like Insight Partner, Goldman Sachs, Sequoia, Tiger Global, and etc. And my name is Connie Lam. I'm usually from the engineering team that were responsible with most of the auditing business line and the incident response. So by overseeing the incident response, it really gives me the very first-hand exposure about some of the incidents or maybe like cross-stream breaches that are happening on the current market. And for supporting the Avalanche, CertiK has always doing like a long-term support on the Avalanche network. So far, we have done like more than 250 projects audited and successfully helping them to launching on the network itself. But this is also some of the highlighted features and projects that we have listed here. So this year, the blockchain hacks has been happening a lot, right? Until August 12th. There is already more than $1.73 billion of exploit. And the next slide, we're going to summarize some of the notable blockchain incidents that are happening from the beginning of the year until now. You can see like over month by month, you were seeing a lot of number was showing up here. And the categories was mostly were related to, cross bridge and some of the DeFi application exploit and maybe like governor attack. So, and next slide, this is the summary that what we make about the previous two slides. You can see like the cross-bridge incident has been making like more than $1.3 billion accidents. And most of the time they were caused by the private key leak, maybe vulnerability on the verification design, malicious transaction or signature, etc. Governor attack, which is also one of the rising star, which has been making like $200 million loss. And then the last one would be like some of the smart contract vulnerability that were kind of in a trivial mistake that were, for instance, a lack of the validations, re-entrancy attack, price oracle manipulations, foul logic error, and also the lack of access control. But today, since like the cross-bridge incident has been making the major number, so we're going to focusing discussion, can we do better on that part? And how can we prevent some of the similar mistakes that were happening in the past? Yes, so this is a few of the topics that we're going to go over. What is a cross-stream bridge? What are the common security issues? What are the lessons learned? And then what to do if really there is a case happening, right? So what is a cross-stream bridge? In short, cross-stream bridge is helping individual to moving and transfer their digital assets from one blockchain to the other one. And below, this is a typical 4-step that a user will be experienced on when they were interacting with the CrossStream bridges, right? The first one is user making a deposit on the CrossStream from the original chain A, for instance. They will make the qualification how much amount they want to transfer and which network they would like to receive the money on. And then lastly, there will be like a verification proof to make sure that the transaction is intended to happen on the chain A. And finally, and if everything goes well, then the user able to restore the assets from the chain B, which is the destination chain. So in here, according to the past couple incidents that happened in the cross bridge, we identified that there is a few of the common attack vector that could be usually happen. From the diagram on the right-hand side, we can see that usually a attacker will inject with a malicious data on what we call a spoof data, and then it will go into a defective verification process bypassing the verification on the original chain. And then it will generate a proof of a non-existing asset and then pass it to the bridge. The bridge will communicate to the destination chain and the chain, which is the chain B. In chain B here, they see everything is going well. So they allow the hacker to receive the money that they were specifying. So in here, I would just take into one of the example, go into a little bit detail, what are the true scenario happening. So from the left-hand side, the figure is a destination chain. So the user actually is trying to make a deposit in Ethereum blockchain, and where they want to receiving the fund from the destination chain, which is a BNB chain here. So now let's get a little bit deeper, closer check about what happening within the deposit functions on the Ethereum blockchain. Yeah, so in here you can see this is actually the smart contract from the Qubit Bridge functions deposit. You will see that the deposit function are passing the 3 parameters. One is the destination domain ID, the resource ID, and call data. We're going to go over step by step to see what's happening in the code and how the hacker able to transfer the $80 million out from these whole entire transactions here. So in the first step, they are doing a really good check is to validate if a user have enough fee to pay for the transactions. And then later on, they will using the passing resource ID to matching the responsible handler contract. And they do have a check for make sure that the handler contract is a validate contract. And then they will increasing the deposit nonce with a given destination domain ID, which is really good. If every check pass it, right, and then they will go to calling the handler contract with the deposit function and passing along with the resource ID, the message sender, which is the one that we're calling the function itself, and with the given input data here. And at the end, you will see that the engineer doing a good job. They emitting a deposit function just for better logging and chasing perspective. Now, let's getting into a little bit deeper close into the line 208. What's happening inside the handler deposit functions? So this is the function that from the handler contract that we're just seeing from the line 208. The deposit function is still very similar. It's passing 3 parameters. One is the resource ID, the depositor address, and also the passing along call data. So at the beginning, they were trying to decoding the data to extracting the options and the amount that they would like to transfer or maybe making the deposit on. And then lastly, and the next one, the 927, they were utilizing the passing along resource ID to find a matching token address contract. And then in here, 928, they do check if the passing resource ID and return the token address is a whitelisted contract address, which is a legitimate contract in their products, right? And from line 130 to 135, it looks like they have a special logic to handling if the token address is a burn address or not. So in here, we will skip the burn part because we verify this is not like nothing to do with the burn logic. So we will directly jump to the line 134. In line 134, there is a check about saying like the deposit amount has to exceeding the minimum requirement for the bridge to make the deposit on. And then the last one, 135, if everything looks good, then the token contract will make the safe transfer from this contract address into the depositor address and with the given amount, right? You will see like the function, the engineer is doing a really good job. We're doing a lot of check, but how come it's still bypassing all the validations here? And after decoding with the core data, we realized there are a few things we're doing wrong and making worse the loophole that the attacker able to play around with the game is, first is a resource ID that they're passing actually return a zero address for token address, meaning that actually there is no found token address were whitelisted here. But in line 128, whenever they were checking if the contract whitelisted address is a legitimate contract, for some reason, the contract whitelisted mapping, they were putting address zero as like a legitimate contract. So they passed the check line in 128. The first check go in. And then inside the core data, we find out that the attacker actually wants to make a deposit of 190 ETH, which is exceeding the minimum amount. So line 134 got checked. And now it come to here is if the token address is everything looks good, then execute. And this is where another problem here is. Token address in the Ethereum or maybe Lost Solidity is an EOA account. So from the low level call, the safe transfer from will always return success. Meaning that even though the contract address is an address zero, they were still passing and never will got reverted in line 135. So all the chat proof, there is a lot of chats, but none of the chats were able to provide the guardians to preventing the exploit. So this is one of the biggest mistake, but it's not the last one. There is another issue we're also causing the problem is after analyzing and decoding, understand how the interaction and the core data were passing, we look back into the main contract here. Oh, sorry. Yeah, and we find out that actually within the contract itself, they have two deposit functions. And they have a very similar, input parameter where you can see it's a domain, destination domain ID, resource ID, and core data. But you can tell from the name side, it's like one is deposit and the other one is called like deposit ETH. So what we believe is that the deposit, the engineer were intended is like they allow each of the user, if they want to deposit any of the ERC20 token contract, they can call this function. And deposit ETH will be particularly only handling for depositing the ETH type of tokens. But now, what is the problem here? You can pretty much you can tell aside from the line 209 and 225. They actually are sharing the same event log, meaning that deposit a ERC20 and deposit a ETH is not making a huge difference from the login system, right? And what that reflecting means is, meaning that you can deposit one Apple coin maybe, and then you will receiving an entire one ETH. So you're comparing like Apple and Orange. So this is where people can making the profit from. So some of the summary, what we learned here is, first, you always need to separate the token operation and even the event logs. Don't try, sometimes we understand engineer were doing like a quick job, but don't try to write some, sloppy code, because one line of code will making like a huge difference. If this is two obligations and behavior, even though it's very similar, just try to separate it out. And then we always recommend to verify all the injected input. Even though this is a simple validation, you still have to do it. Always keep the eyes, maybe learn from the most recent exploit, seeing like, is there any similar vulnerability might be causing, or maybe like sharing within your contract. And then also like, if times allow and your budget allow, always looking for like auditing on the core component of each of the sides from the bridge. So now this is some of the few items, like if just in case if there is an incident happen, if you're building a cross-bridge solution product. So very first hand, what we recommend to do is first pause the token transfer and related functions first, held the product, and then immediately informing the community, exchanges, and maybe like platform partner, just make sure that they were able to monitoring the money movement. And then setting up the community channel, bridging and inviting the respective team from the security expert, or maybe like your order like security engineer quicker to identify the issue. And then don't try to be rushed, but always like doing a patch fix in terms of identifying, verifying, and then test it, and then lastly like deploy it on the mainnet. And then at the end, will be highly recommended is like making an assess on the damage, evaluate how much you can work with the community to making the transparency on how to recovering with their loss, or maybe like how to helping the project to be moving forward in the next steps. So in here, the best practice, I would say like the best practice for Web3 is very similar to a regular software development practice. So we always wishing the team that can have like at least like a peer review on the design on your white paper, or maybe like some of the tech stack, understanding the complexity of the system and each of the module, to have several rounds of discussions, and then usually perform like code review during the development cycle. At least I will have multiple eyes. People were able to capture some of the fault ahead of time. And at the end, always writing tests, even for common corner case and system integration tasks. I know that this is a lot of work, but this is highly recommended to have it. If your team also having a resource allow, we recommend to create like a written threat model to identify which are the weakness part of your system. And then it probably can also work with some of the security expert in the field to, when you guys having like a security audit, you can share with them. It's like, this is some of the item that we might having a concern. So the security expert might have a knowledge about, okay, how to do, or maybe providing recommendation on the particular review sessions. And then at the end, so make sure you will, if anything's allowed, it's like getting a source code audit on every single change commit that you guys have made. And thank you so much for everyone. And this is my presentation. I hope you guys enjoyed it. And if you have any questions, we have few folks that will be staying around to answering all these like security questions. Thank you.